Hello, welcome to the introduction for Lab 5, a Google Earth lab on folds and folding. On the left here we have the lab document with an example image. This is an image of a doubly plunging anticline. The elongated oval shape lets you know it's doubly plunging because it pinches off in the top right and it pinches off in the bottom left. It's not a rounded structure, so that's how you know it's not a dome or a basin, but rather a doubly plunging either anticline or syncline. And then you have to look in close at the beds themselves that are exposed to find out, are the beds coming up towards the center or down towards the center. And in this case they are tilted up towards the center. I'll take a look at one in Google Earth to help you. I can scroll down here, and this time I'll take a look at the last one. Put that into Google Earth, hit enter, and it'll fly right to it. Just like in Lab 4, we want to worry about the altitude so that we can tell, okay, what is the structure that we're supposed to look at. So we scroll out until the eye altitude is right about 6. And so you can see this long structure going from the top left to the bottom right on the screen here. That's the structure in question. However, at that altitude, you can say, okay, this is what I'm supposed to look at. However, it's kind of difficult to tell what you're looking at. You have to both zoom out and zoom in to be able to fully identify the structure. I like to zoom out first. Gives me, the broader perspective. So as we zoom out, if we zoom out really far, we can see that it's a kind of small, long, skinny structure between some bigger things like this here to the southwest, and this here to the northeast, and even this one to the northeast. So if we zoom in, double check our settings by going to Tools and Options. Let's increase our vertical exaggeration to 3. For the folds, that's almost always the preferred option to have set. Now we can hold down Shift and the mouse button and pan around, and we can see that this structure that was on the southwest, when we have north facing up, this is the southwest of our desired structure to identify, is first of all a hill. Now, one important thing is that just because something's a hill does not mean it's automatically an anticline or automatically a dome. It means erosion has left it higher than the land around it. You can have a basin eroded such that there's a hill. You can have a syncline eroded such that there's a hill. Or you can have a valley eroded through an anticline. So we identify it as a hill. That's a start. And on the right hand side, the north side of our desired structure is another smaller hill. Our structure itself is a valley between those two hills, but it has its own hills right in the center of it. Kind of very narrow and pointy hills. But remember, they're not quite as pointy as they look right now because we have vertical exaggeration set to 3. So this hill looks 3 times as tall and pointy as it really is. What we want to look at to know if we have an anticline or a syncline is the orientation of the beds. Now, we just have an image. We can't go and dig and expose the beds, but erosion has exposed a lot for us. If we come over here close to the little pin and we tilt it down, we can tilt it and pan and look carefully and try to identify where it changes from one kind of rock to another. Usually there's a color change, like this lighter colored rock here and this darker colored rock here. So that's the change of a bed. In this case, we notice as we look down this north face of the slope, it's a fairly consistent color. We don't see this lighter rock exposed here. We see all this kind of little bit darker speckly rock. Along the ridge here we see the change, the contact between the darker rock and the lighter rock. This makes us think, okay, this is probably tilting to the north. It's basically like a dark colored book set against a light colored book and angled such that it slopes down to the north or up to the south, same thing. If we look on the other side of the hill to say, okay, if this is a stack of books tilted north, on the other side of the hill we should see the edges of a few of these books. We see it go from dark to light, back to dark, back to light, back to dark, back to light. So we see a bunch of layers as we go down the south slope. On the north slope, we saw mostly just one color, except when we get down here and we have a few new layers exposed. But for the most part, this face is one rock exposure. So this tells us that the rock beds are tilting down towards the middle of our structure here on this side. If we pan out a little bit and we come over here, we can see that it looks like they're tilted in the same direction. Let me zoom out a little more, come over to the other side, and it's the exact opposite. So this hill is indeed an anticline right next to our structure. We look on the opposite side and we have the same thing. So we have a structure between two anticlines where the beds are tipping down into the center of our structure, making it a syncline. So despite the fact that we have a hill in the middle of our structure, the structure itself is a syncline eroded away to leave a hill in the middle. So the fact that there's a hill doesn't make it an anticline. It is a syncline. The only other thing we need to determine is it plunging and in which direction? So we pan out and we can see it's wider on the east and narrower to the west, pinching off to the west. So for a syncline, the direction that it opens in is the direction it's plunging. When we have an anticline, the direction that it pinches is the direction it's plunging. If you take a piece of paper and you fold it into an arch, and then you tilt it either towards you or away from you, looking along the ridge, you can see how as you tilt an anticline shaped piece of paper away from you, that if you eroded the top off, it would narrow and pinch away from you, the direction that it's plunging. If you bend it into a syncline, you'd have the opposite. If you tilt it towards you, and you imagine the top getting eroded off or cut off with a pair of scissors, the opening would get wider towards you, and it's plunging towards you. So what we have here in this example is a northwest plunging syncline. And that's the kind of thing that you want to do for each of these different locations in this lab. And for fold type, you want to be identifying, is it an anticline or a syncline? Is it plunging? If it is, which direction is it plunging? Or is it a basin or a dome? To be a basin or a dome, it has to be very close to circular shape. It doesn't have to be a perfect circle, but clearly not an extremely elongated shape, much closer to circular. And then you want to look at the direction of the beds, not just does it look like a hill or a valley. Which way are the beds tilting? Are they tilting up towards the middle and down towards the sides, making it a dome? Or are they tilting in towards the middle and up away from it, making it a basin? So the goal is using Google Earth with a vertical exaggeration enhanced to help you see the structures better and the bed tilts better. Get practice identifying what kind of fold you're looking at. That way, if you're out in the field, on site, looking at an exposure, a hillside or a valley, you can see the beds and see what kind of structure you're looking at. And this can be useful whether you're simply doing geologic mapping or whether you're planning a drill site or a construction site or something like that. Part 2 is just like part 2 in the previous lab. You just talk about what was the hardest thing for you in identifying these folds. Was it seeing the beds? Was it remembering which way the plunge goes? What was the hard part for you? And now that you've done the lab and worked through it, do you think that if you saw this in person, you'd be able to identify it?